I wanted to show you that this answer does work, okay? Let me just show you that it does work. Like you do get this. This does solve the equation. We're saying -1 works, right? So let's plug -1 in here. We get log base 5 of what? 5 plus log base 5 of 1 equals 1. Is this true, right? Well, hopefully you recognize this. That was a property. Or you could also just use your change of base formula. What would you type into your calculator there? ln 5 over? And that's got to be 1, right? That's 1. So this is 1. Plus, and then when you plug a 1 into any log, what do you get? 0. And that's true, right? Okay, that's just showing you that we did solve the equation. All right, let's look at what they've got up for us next. Okay, here's the next one. The natural log of x equals the natural log of x plus 6 minus the natural log of x minus 4. We've got logs everywhere, don't we? That's the natural log though, right? Okay. So look, let me ask you something. If this wasn't here, what would you do? Do you need the loop? You'd set the arguments equal to each other, right? You'd set x equal to x plus 6, right? That's what you would do if this wasn't here, but it is. So we can't do that, right? You can't do a loop because for the loop you need, right, a log, you need something here equals something, and then you just do your little loop. We got too many things, right? Too many logs. So look at the right-hand side. What can we do to the right-hand side? Condense it again, right? Condense it into a single log. Because it's 2 logs with subtraction. That becomes 1 log with division. Okay, let's rewrite it. So these 2 logs come together, become a single logarithm, but inside we're going to have division. What's the numerator? The first one, x plus 6. Good, and the denominator is the x minus 4. Now you can set them equal to each other, right? Now you can set the arguments equal to each other because you're saying the natural log of x must equal the natural log of this. So I'm going to set the arguments equal to one another. I'm going to set this equal to that. So x must equal x plus 6 over x minus 4. And what you're now looking at, that right there, it's not a quadratic equation, is it? Not right now. It's called a rational equation. And if I'm not mistaken, let's see here. Let's look at our calendar. Hey, guess what? If we look at our calendar, do you see back in August, early September, section 1.4, no. Where is it? R7, rational expressions. See that rational expressions? Right? We covered in the beginning a review of how to solve things like this. So, anyone remember how we solved that equation? Multiply both sides by x minus 4. You're clearing the fractions, right? So we're going to multiply both sides by x minus 4. This is a rational equation. So if I multiply the left side by x minus 4, I'll have x minus 4 times the x that was there equals the right side, x plus 6 over x minus 4. I'm multiplying that side by x minus 4 as well, right? That has the effect of clearing the fraction out. So what happens on the left is we can distribute the x through to both of those, get x squared minus 4x equals what happens on the right? X minus 4 cancel. That's the whole purpose of bringing in the x minus 4, so we don't have a fraction anymore. We have x plus 6, right? And now what are you looking at? What is this? It's a quadratic equation now. In this quadratic equation, you can move everything over to one side. Set it equal to 0, then you either factor it or use a quadratic formula. Factoring is superior, right? If it works. What are the factors? So x, what? Minus 6 plus 1. And now you solve each of those, right? You set each of these equal to 0. I'm going to actually write it down. Normally I just give you the answer here, but I'm going to write it down because I want to make a point. All right, set each one equal to 0. And you solve these, right? Add 6 to both sides, subtract 1 from both sides. You get your two potential answers. We'll have to check them. So here's what I want. I really like this problem, and this is why. We started out, what type of equation was this when we started? This is a log equation, right? And to solve this log equation, right, to solve this log equation, we had to be able to solve a rational equation, a quadratic equation, and 2 linear equations, right? So that's why when you're learning how to solve equations, the reason is that when you try and solve more complicated equations, you need those techniques to solve them, right? So if you struggle with quadratic equations, rational equations are never going to be easy to solve. And if you can't do rational equations, you can't do certain types of logarithmic equations. So it all builds on itself, right? All right, we need to check these answers. So let's try 6 first. 6 plus 6, oh, sorry, over here. 6, yes, that's positive, right? 6 plus 6, positive. 6 take away 4, positive. So the 6 works. Negative 1. Nope. Done. We don't have to check anything else. We throw it away. Okay? Throw it away. So we only have one answer. Again, I'll say it last time. The fact that this is negative right here is not why I'm throwing it away. I'm throwing it away because when I plug it in, what's left there is negative. So that's it. Those 3 examples I just gave you are the only 3 examples in the book. Like, you know, not the example. The exercises has a bunch, but like when they're trying to, like if you're reading the book, that's the 3 examples they give you. So I think we need to potentially do a couple more. So let's go to the exercises, and I'll let you look at those. Take a second to look at those. Look at the even ones here. And we'll do maybe two or 3 of those. Let's see, do they get worse? Yeah, let me scroll down a little bit. I will not give you one with an absolute value. Okay, we won't worry about that right now. There you go. Look at those right there from what you can see on screen. And why don't you pick one?
25, 35.
25 first?
Yeah.
Okay, 25. 25 is, yeah. How about instead of 25, let's do 28, because 28 has one more thing to it that 25 doesn't have. And I did one pretty close to 25. Sorry, I ask you what you want to do, and then I make the decision. Sorry. Okay, log base 5 of x plus 3 equals 1 minus log base 5 of x minus 1. All right, so unfortunately we have a 1 right here. And what makes that unfortunate is because if that wasn't there, then I would just set the 2 insides equal to each other, wouldn't I? But it's there, so I can't. Yeah, so we can't condense yet, right? Right now we can't condense because we don't have 2 logs right next to each other with subtraction or addition. unless I first make the conscious decision to take that negative log on the right-hand side and move it to the left. So when I move it to the left, it becomes positive, doesn't it? I'm going to do that first. So I'm going to have log base 5 of x plus 3 plus log base 5 of x minus 1 equals 1. And that's so that's why I didn't do number 25. Do you see number 25 is pretty much like that's where we are right now? It's two logs together with plus between them equals 1. All right, now we can put these together, can't we? Condense these into a single log base 5 of two things multiplied together, right? X plus 3 times x minus 1. And then that must equal 1 still. This is very similar to the problem we did just a minute ago, isn't it? Multiply those things together in the middle, or inside that log. We're going to get log base 5 of, let's see, x squared plus 2x minus 3 equals 1. Now what? You finish it. I'm out of markers. Let me go get a few markers. Loop time, right? Is that what you do? 5 to the 1 equals x squared plus 2x minus 3. Fortunately for us, 5 to the 1 is 5, right? So 5 equals x squared plus 2x minus 3. What type of equation is this? Quadratic. Move everything to one side. 0 equals x squared plus 2x, what? Minus 8. And then hopefully that factors. If it didn't factor, we would just use a quadratic formula, all right? So it does factor, I hope. Plus 4, x minus 2. Set of each of those equal to 0, negative 4, and 2. Got to check them though, right? Always checking them in the original. Negative 4 doesn't work. Right here, doesn't work. You could also check it here, it wouldn't work here. But throughout the negative 4, does 2 work? 2 does work here, 2 works there, so we're in business.
If none of them work, you say no.
If none of them worked, you would say no solution. And if both of them worked, just give 2 answers. Okay, yes?
So like for 33, does it matter if it's log to the 1/3?
No, let's do 33 then. Yeah, 33 looks interesting. So for 33, we have log base 1/3. Don't let that freak you out. Then you have x squared plus x. And then we have minus log base 1/3 of x squared minus x. And then equals negative 1. All right, I cannot do a loop, right? I cannot do a loop right now because I have 2 logs on the left-hand side. I really wish it was 1 log, right? Because then I could do the loop. But I can make it 1 log, right? I have subtraction between these two. Subtraction of 2 logs becomes log of division inside of 1 log, right? So log base 1/3 of, let's see here, x squared plus x over x squared minus x, and that must equal -1, right? You all right with that? There's a couple of different paths to go down right now. So I'm going to let you lead the way. As long as it's legitimate, I'll go down that path. What would y'all like to do?
Can we change, oh, wait.
Hmm?
If it were negative, if it were just 1, could we do log 1/3 to the 1/3? Because it equals the same. And then we can,
You could do log 1/3 of 1.
no, because that would
You-
be 0, right?
Wait, what are you trying to do? I'm misunderstanding.
So like if it weren't a -1, if it was just a 1, could we
Oh, are you saying could you do log 1/3 of 1/3? Yes, and then you would be setting
equal that to 1/3? Or no?
close. But I think you're working too hard. I mean, we could go down that road, but
Not now because it's a negative.
it's a -1, right? But
Can you multiply log 1/3 to the other side and it becomes?
you can't, no, don't look at this as like a number. You can never like do like multiply this or divide this. How about this side of the room? Anybody have an idea? No, I mean, not to, but I do want, nobody's saying anything. I'm just seeing stares.
Could you just multiply the denominator and cancel out that side?
Multiply, what do you mean multiply? Oh, clear the fraction. You can't. This is all trapped inside of this log. So you can't do something over here and cancel. You can't push like anything algebraically into that. It's trapped in here. You gotta wait. Yes. Do the loop. What? Yeah. Do y'all see it? I mean, what was the point of making it into one log? To do the loop, right? So just do the loop now. It's a fraction. It's okay. Life will go on. Let's see what happens. This is 1/3 to what? To the what? -1,
Which is a 3.
which is just a 3. Because any fraction to a negative power just flips it, right? -1 flips it. But we'll deal with that. We'll deal with that in a second. Equals what? X squared plus x over x squared minus x. So there's a I think there's a big difference when you're sitting there as a student of math, right? Trying to learn math. There's a big difference between like sitting there with the idea that, you know what, I need to see if I can just like replicate what my teacher's doing. Monkey see, monkey do. I'm just going to copy what they're doing. There's a difference between that and actually understanding what you're trying to accomplish, right? So like, why did we do that? So we could do the loop, right? If you're thinking of it more of like, okay, he put them together, so I can put them together. And then that's it. Now what next? Oh, well, he did the loop, then I can do the loop. No, it has to be, what are we trying to accomplish, right? What are we trying to accomplish? We're trying to get this out of here, right? Get these x's out of the log. The only way to get the x's out of the log is if we somehow at some point use the loop. But we got to get there. So, all right, back to this. So this becomes 3. Are we comfortable with that? Mistakes I see on exams, students will turn this into -1/3. Right? They'll just say, oh, that's negative. That's like a -1 times that. It's not. It's the reciprocal. Okay, now this side is this, and what type of equation is this? Rational. So how do you solve a rational equation? Multiply both sides by the fraction, the denominator, right? Clear the fractions. So I'm going to multiply the left side by x squared minus x. Multiply the right side by x squared minus x. And we get 3x squared minus 3x equals, what happens on the right? Y'all know what I did? Distributed 3 through, right? Okay. And they cancel, and I just get equals x squared plus x. All right, what type of equation is this? Quadratic. How do we solve quadratics? Move everything to one side, right? So let me subtract x squared here and here. So that gives me 2x squared. And let me subtract x here and here. I get minus 4x, right? All right, so I'm subtracting x squared, subtracting x squared. I'm subtracting x, subtracting x. That gives me 0 over here. Over there, I've got that. And how do we factor that? Yeah, GCF, right? Greatest common factor. Just they both have something in them, right? So both have a 2, both have an x, right? 2x comes out. You're left with x minus, careful, we pulled a 2. So x minus 2.
So 0.
So set those both equal to 0. Now we have two little linear equations. X is 0 is one potential answer. X is 2 is the other potential answer. 0 doesn't work or does work?
Yes.
So think, if we plug 0 in here, you get 0. Can you plug 0 into a log?
Oh, no.
Has to be positive, right? Has to be positive. So 0 can't go in, right? That won't work. How about 2?
Yes.
2 works? Yeah, 2. 2 will work here. 2 squared plus 2 is going to work. And 2 squared is 4. Take away 2. That's still 2. We're good. So our only answer is 2. All right, let's do one more. And I'm going to go pick one of these ones on the bottom there. Yeah. Let's look at 38. 38? 38 looks fun. .38 is log base 3x minus 2 log base 3 of 5 minus 2 log base 3 of 5 equals log base 3 of x plus 1 minus 2 times log base 3 of 10. All right, I have all that there. Lots of different ways to go about this problem. What I know is that I've got x's inside logs. So hopefully I'll use the loop at some point. Maybe not. I might not need the loop if it comes out to be as simple as the very second one I gave you, where it was log of something equals log of something, and you just set the insides equal to each other. Maybe it'll turn into that. I mean, I've got logs everywhere. So any ideas to start? What do you got? You want to do what? So you want to take this -2 and push it up here and make that 5 squared. Is that legal, everyone? Okay, so I'm okay to do that? Was that it? Okay. How about the 2 on that one? You want to do that one as well? You'll move that 2 up? So is that legal? Is it going to help us get to the answer?
Yes.
Maybe. I don't know. It's legal, though. We can do it, right? So let's do it. Let's try it. We may wind up turning back and saying, you know what? No, that didn't really help. If we push the 2 up, it becomes log base 3 of what? 25. Do I need to show that? 5 squared? Equals log base 3x plus 1. And then minus, we push the 2 up, we get log base 3 of what? 100, right? Because you're squaring the 10. All right. Okay with that? That was legal. Anything else you'd like me to do now? Combine the logs, you mean?
Yeah, kind of, but like move to where one side is only going with the x, and then one side is only going.
So one suggestion right now is that we can take the logs that have the x's and move them to one side, and things that don't have x's and put them on the other. That would be legal. Do we have to? No. We can. Does anyone have another suggestion? Condense each side right now. You could do condensing of this and condensing of this, right? Here's the good news. Both ways are going to work, but it's just a question of which way do you want to go. So how many of you want me to get all the logs with x's on one side, the things without x's on the other? How many want me to do that? How many of you want me to condense just right now? Okay, I'm condensing right now. All right? So if I condense these two logs into a single log, I'm going to go and create one log with division, right? So it'll be log base 3, and inside of this will be x over 25. That's it, right? And then this side, we're going to condense as well. These two logs condense into one. We have division again because there's subtraction. It'll be what over what? X plus 1 over 100. That's fair. Now what? Yeah, we have a log base 3 of something equals log base 3 of something. So that means the two arguments must be equal. This is the second example I gave you of log equations. They're exactly the same logs, equal, so I can set this equal to this right now. So I can set x over 25 equal to x plus 1 over 100. And again, there's all sorts of ways to solve this. I would multiply both sides by 100 because 100 is a common denominator of these two, right? You could also do this thing that they teach in school of cross multiplying. I mean, what do y'all want me to do? Multiply both sides by 100 or cross multiply? 100? Cross? Everyone's going to do something different potentially here. I'm going to multiply by 100. Let's just do it. 100 here and 100 here. It's going to clear my fractions, right? 100 divided by 25. 4. 4x equals, the hundreds go away, you get x plus 1. Can you solve that equation? I hope so. This is linear. It's not even quadratic. It's even easier, right? We just subtract x on both sides. You get 3x equals 1. And divide both sides by 3. 1/3. X is 1/3. I think, I don't know, I have to check it. Check my answer. So if I plug 1/3 in here, that's okay, that's a positive number. I don't care about this, this doesn't have x. 1/3 plus 1 is still a positive number, so this should work. Okay. That's it. I've tried to expose you to several different types. Obviously, you can see the homework set there is a lot of practice for you, right? I recommend that you look at the odd numbers to at least start. Okay, so the review. I sent out a review, a week or so ago, just to kind of get you started with practice, right? Yes? Okay. So what I typed up before class is I went through our ebook, okay? I went through our ebook. I'll let y'all take a picture of that if you want, or just write it down. Let me make it a little bit bigger. Let's see if I can make that a little bit bigger. This is from the ebook. If you look at those pages and those problems, that's where I'm going to take the exam from. So I know I sent you that review. In that review, there is some overlap with this, for sure. But I kind of sat down this morning, I said, let me just start from scratch. What am I going to do to make this exam? And I went through everything, and I said, these are the problems right here types of problems that will appear on the test. All right? Everybody have those?
Are you able to put those on the announcements board?
How about one of you do it?
I'll do it.
Yeah, there it is, right? You let everyone else know. Yeah? Okay.
I'll upload a picture.
Yeah, I don't care what you do. Yeah. Send out an email to the class or whatever. I'll put it on you. So when I was in college, it was way before all this technology, right? Like I had a tape recorder. Actually, they had just gone to digital, so it was a digital voice recorder. And I'd have to ask my professor if I could record them. And like everyone in the classroom, like not everyone, but a lot of students had these voice recorders. And then you would go home and listen to your professor. This was more for like chemistry classes and things like that. You're like, what did he say? Right? Yeah, like a little MP3 recorder. So anyway, my point is, especially when you get to a university, you go to class, the information that's disseminated there, it's your responsibility to take that information, right? Your instructors very seldom are going to go out of their way for you, all right? Like me recording a class for you and putting it on YouTube, like, you're welcome, you know? Like, when you get to a university, do not have that as an expectation, right? So it frustrates me when I have students that are like, well, I'm not sure how to do that. Well, I recorded the entire lecture. Have you watched that? No. Well, you know, I mean, what are you going to do when you get to university when that lecture is all you have? Like, what you remember in that lecture is all you have. So anyway, we want to work on that, right? Just work on becoming what's independent learners. That's the terminology. I want all of you to become independent learners. So what should we do? Let's look at these problems, right? Let's look at them, and then what we can do in the next, 40 minutes, 35 minutes, is let's go to page 410. Let's look at number 21 through 25. I'll let you pick a problem from there. We'll do it, and then we'll just see how far we go, okay? I think it's still open, hopefully, here. Yes, it is. This is page 410. It was problems 21 through 25? Yep. Let me zoom this in so you can see what we're talking about here. So this section had to do, look at number 21 through 25 there. Solving inequalities. There were nonlinear inequalities. So there were like polynomial inequalities and rational inequalities. This was not on our last test. It's where we stopped. And so this is going to be on this test. I believe this is this comes from 5.5 out of the lecture, section 5.5. So 21 and 22 are similar. Would you like me to do one of those? Or would you like, those are polynomial inequalities. And then the other one, 23, 24, 25, those are rational inequalities. I'll get it. So what would you like, polynomial or rational? I think the rational is harder. But there is a YouTube video of me doing both types. And I'm telling you to review all of these. So I'm saying to you that you should be able to come in here and solve either a polynomial or a rational inequality on Tuesday. So which one did you want me to do? You said rational, but which one? 24? Yeah? The only difference between 24 and 25 is on 24, everything's